going into detail for working principle of three-phase induction motor, we first need to understand what is rotating magnetic field. Here the name suggests that whenever we give three-phase supply to the stator winding, the stator winding produces a rotating magnetic field. Rotating magnetic field म्हणजे काय? Suppose, sorry, stator. There will be slots. So obviously these are the slots from the inner periphery, and there will be three-phase winding. At one point, suppose this side produces N pole and this side produces S pole. So what happens, as it is a three-phase supply, so there will be a rotating magnetic field. So what happens, after some times there will be reverse in the magnetic field. So that means here previously S pole, now it will change to N, and previously there was N pole, now it becomes S pole. So this is what the reversing in the magnetic field. So this is not like suddenly it becomes N pole and it becomes S pole. So this is what the rotating, as this complete rotation will be 360 degree. So there will be a rotation of this magnet. So this is called rotating magnetic field due to three-phase supply. So that we have to see. तर ही rotating magnetic field produce होते, बरोबर, three-phase supply दिल्यानंतर. तर ती कशी produce होते? Why it is rotating? That we need to understand first in this topic. Then we'll see the actual working principle. Obviously, the working principle of the motor will be same. The DC motor चे working principle होतं तेच असणार आहे. Whenever the current carrying conductor placed in magnetic field, it experiences a force whose direction is given by Fleming's left hand. फायनल वर्किंग प्रिन्सिपल तेच असणार आहे. फक्त याच्यात काय की रोटरला आपण सप्लाय नाही देत. जसं डीसी मोटर मध्ये रोटरला आणि स्टेटरला दोन्ही ठिकाणी आपल्याला सप्लाय द्यावा लागतो, किंवा स्मॉल मोटर असेल तर मॅग्नेटिक फील्ड परमनंट मॅग्नेट मोड प्रोड्यूस होते. तर तसं याच्यात काय की रोटरला सेपरेट सप्लाय नाहीये, तर रोटर मध्ये जे ईएमएफ इंड्यूस होत आहे ते ड्यू टू फॅरेडेज लॉ ऑफ इलेक्ट्रोमॅग्नेटिक इंडक्शन. जसं ट्रान्सफॉर्मर आहे, ट्रान्सफॉर्मरला प्रायमरी वाइंडिंगला आपण सप्लाय देतोय आणि सेकंडरी वाइंडिंग मध्ये ईएमएफ इंड्यूस होते. Right, this is what the transformer action, and the EMF induced in the secondary is due to mutual induction. So same phenomena is here, right? We are giving three-phase supply to the primary winding. Here primary winding is stator, and the EMF will be induced in the secondary winding, and the secondary winding here is the rotor. In squirrel cage there will be a rotor conductors, rotor bars, which are made from thick copper strips or aluminum strips, and in wound type there will be a same number of turns as that of stator. So this is the difference. So we can say three-phase induction motor which is a rotating transformer. आपण त्याला असं म्हणू शकतो, कुठेतरी ग्रुप मध्ये तुम्हाला दिसेल ते नाव दिलंय त्याला, रोटेटिंग ट्रान्सफॉर्मर. Right? Okay, so let us see what is this rotating magnetic field and how it will be produced. So as we know, whenever the three-phase winding is energized from three-phase supply, rotating magnetic field will be produced. This field is such that its pole do not remain in fixed position on the stator, but go on shifting their position around the stator. So as I said, these NS pole which are continuously shifting from their position. For this reason, this is called rotating magnetic. And we have to prove it now that the magnitude of this rotating magnetic field is equal to 1.5 times phi m, where phi m is the maximum flux. Right? Now to see this phenomena, we'll consider a two-pole three-phase winding, and the three phases are XYZ, which will be energized from three-phase source, and the respective current in these phases will be Ix, Iy and Iz. आपण 3 phases consider करू XYZ. त्यामध्ये जे मॅक्झिमम फ्लक्स असणारे phi m असणारे आणि करंट असेल Ix, Iy आणि Iz. Ry बी आपण consider करू शकतो. That is what the 3-phase supply, red, yellow and blue. So here in book it is given XYZ. So I took the same notation. Now in first year you have seen the basic introduction to 3-phase supply, right? So what will be that? If there is a 3-phase supply, then their voltage is 440 volt, right? And the frequency is 50 hertz. And as the supply is sinusoidal in nature, it is pure AC alternating current. So their waveforms will be like that. Look at this. The waveform for the first phase, suppose the phase X, which is the reference phase, right? If this X is the reference phase, then obviously this will start from the origin. So this is starting from the origin, completing its half cycle at 180, and the complete cycle will be 360. Obviously, so this is for phase X. Similarly, phase Y, where will it start? This point, and this point will be 120 degree. Similarly, phase Z, which will start from 240 degree. So in between each phase, there will be a difference of 120 degree. Why 120 degree? Because the complete rotation will be 360 degree. So divided by 3, there will be 3 phases. So the value will be 120 degree. Right? So in between every 2 phases, there will be a difference of 120 degree. So the complete phase diagram, complete waveform for 3-phase supply, it is like this one. So you can plot this waveform. You already plotted it in first year also. So this is the complete waveform. Now from this waveform we can draw the phasor diagram. So look at this. This is the phasor diagram for this. Very simple. The phasor is nothing but, phase diagram is nothing but, there will be an arrow, straight line with arrow mark on one side. This is called phase. So this is X phase, Y phase and Z phase. So it always rotate in anti-clockwise. So this is the X, Y and Z. The Y lags X by 120 degree, Z lags Y by 120 degree, and Z lags X by 240 degree. So this is the phasor diagram, where we took X as a reference phase. Right? Now from this phasor diagram we can write the sinusoidal waveform equations. So this is the mathematical representation for this waveform. Phi x is equal to phi m sin omega t. Phi y is equal to phi m sin omega t minus 120 degree. So this is starting from origin. So omega t plus minus, there will be 0. It is starting from 120 degree back of phase X, so it will be omega t minus 120. And phase Z, which is starting from 240 degree back of phase X, so it will be minus 240. So these are the equations from this waveform. So this is what the basic equations, waveform and phasor diagram for 3-phase supply. So it will look like this. Winding will be this X phase, this is the Y phase, and this is the Z. Now we need to consider different instances to understand how the magnetic field is propagated. Okay. So let us consider instant 1. This is from दिस इज द वेवफॉर्म. आता या वेवफॉर्म मध्ये आपल्याला इथं मार्क केलेलं आहे बघा, इन्स्टंट 1 2 3 4. Instant 1 is nothing but the origin, 0 instant. Then instant 2, which is 30 degree after this 0. Instant 3, which is 60 degree after this 0. And this is fourth instant 90 degree. आता हे कसं डिसाइड केलं की कंप्लीट हाफ सायकल 180 डिग्रीची असेल. बरोबर. त्या हाफ सायकलचा हाफ म्हणजे मॅक्झिमम पॉइंट हा कुठे असेल, 90 डिग्रीला असेल. आणि 90 ला 3 पार्ट मध्ये डिवाइड केलं म्हणून हे 30 30 चा डिफरन्स आहे. म्हणजे 0 30 60 90. बरोबर. हा जो मिडल पॉइंट आहे तो 90 डिग्रीचा आहे आणि त्याला 3 पार्ट मध्ये डिवाइड केलं. तर आपण हे 4 इन्स्टंट कन्सिडर करू आणि रिझल्टंट मॅग्नेटिक फील्ड कुठे येते ते आपण बघू. नाउ कन्सिडर इन्स्टंट 1. लुक at this instant 1, put up omega t is equal to 0. आता इन्स्टंट 1 कन्सिडर केला म्हणजे त्या ठिकाणी अँगल काय आहे, 0 डिग्री. ओरिजिन, दिस इज द ओरिजिन. Omega t is equal to 0. Therefore, the 3 fluxes are given by. So we need to put omega t is equal to 0 for phi x, phi y and phi z expression. या तिन्ही एक्सप्रेशन मध्ये आपल्याला ओमेगा टी ची व्हॅल्यू 0 पुटअप करायची. मग काय येईल, साइन 0 0, साइन -120 डिग्री, साइन -240 डिग्री. सो लुक एट दिस. Phi x will be 0, phi y sin -120 degree, so that will be -√3/2, and sin -240 degree, so that will be √3/2. Right? So this is what the values for phi x, phi y and phi z. So we need to calculate the resultant flux now. So we need to calculate the resultant flux, right? So that will be what result. How to calculate resultant of any vector, right? So there will be a vector addition. आपल्याला रिझल्टंट काढायचं असेल, आता इथे 3 फेजेस आहेत, राइट? फेज phi x, phi y and phi b, phi z, and we need to calculate the resultant. Then we need to take the vector addition of phi x, phi y and phi z, like that. Phi r is equal to phi x, then phi y and phi z. So this will be a vector addition, right? Then this will be a vector addition, so we need to convert into polar rectangular form, and the resultant when we calculate, then it becomes 1.5 times phi. So this is the value for resultant. आता इथं दिलेलं आहे, याची ऍडिशन वेगळ्या पद्धतीने केलेली आहे. पण जेव्हा आपण फर्स्ट इयरला शिकलो की मॅथमॅटिकल रिप्रेझेंटेशन फॉर द फेजर, right? So in this case we need to convert that expression into suitable form, that is rectangular. If we are doing addition or subtraction, we need to convert into rectangular form, and when we are doing division or multiplication, we need to convert into polar form. So by using the suitable form, we can calculate the resultant flux, and that will be phi, which is equal to 1.5 times phi, and their angle will be 30 degree. Right? So this is the resultant flux. Now look at this. Look at the phasor diagram for this instant. Phi x is equal to 0. So here the phi x will be 0, so it will not exist. Phi y, which is -√3/2 phi m. So this, as the sign is minus, so for this phasor phi y, we need to take negative of that phasor. So by dotted line, we have shifted to the opposite side. So this will be minus phi y. So it is root 3 by 2. And phi z, it is plus root 3 by 2. So it is, we have to mark on the same existing phasor. So it will be root 3 by 2 phi. Now look at that. As phi x is 0, so resultant phi r will be exactly in between phi z and negative of phi y. So this is what the resultant phasor. So it will be exactly on the horizontal axis of this phasor. Got this? So this is how the resultant flux is calculated, and it will be shown on the phasor diagram. If we see, the phi x will be 0, phi y which is minus, and phi z which is plus. So resultant will be phi z minus phi. Phi r is equal to phi z minus phi. So this is what the resultant. When you calculate using polar rectangular forms, so you will get the value 1.5 times phi m, and their angle will be 30. Okay. Next, at instant 2. At instant 2, we have to put omega t is equal to 30 degree. इकडे बघा. Second instant ला काय आपण 30 degree ने shift केलेलं आहे. Right? So for this instant, we need to again calculate the resultant flux. To put up omega t is equal to 30 in all these three equations. So phi x becomes half phi m, phi y becomes minus 1 phi m, and phi z becomes half phi. It will be same. Phi x and phi z both are same. And phi y will be minus. Now use in the phasor. Phi x is phi m by 2, phi y which is minus phi m. So we have to take it negative, so it will be here. And phi z again phi m by 2. Now look at that. So exactly it is in between z and x and z. It is nothing but on the axis of phase y. So here on the axis of phase y, so this will be the resultant. Now it is shifted by 30 degree from the previous position. So when you calculate this, the resultant will be minus 1.5 times phi. So look at it. The resultant flux is displaced 30 degree clockwise from position 1. Got it? So at instant 2, the resultant magnetic field is shifted by 30 degree. Now look at the third instant. Now put omega t is equal to 60 degree. So therefore the resultant that phi x will be root 3 by 2 phi m, phi y is minus root 3 by 2 phi m, and phi z is sine minus 180 degree will be 0. Sine 60, sine minus 60 a calculate kere later. When you put up in the phasor diagram, so phi x is root 3 by 2 phi m, phi y is minus root 3 by 2, so it is minus, so you have to take it here, negative of that phasor, phi z will be 0. So resultant in between phi x and negative of phi y, so it will be here. Now look at that. Now the complete angle will be 60 degree from the first position. Similarly, instant 4. Put up omega t is equal to 90 degree. So phi x becomes 1, sine 90 is 1, phi y is sine minus 30 is half, minus half, and sine minus 150 is minus, also minus half. So if you use it here, phi m is nothing, phi x is nothing but phi m, phi y is half phi m, so it will be minus phi y minus आणि phi z पण minus. मग resultant कुठे असेल? X axis वर असेल. म्हणजेच resultant flux is displaced by 90 degree clockwise from the position 1. So look at, जे आपण 4 instant बघितले तर त्याच्यात काय, पहिल्या instantला horizontal axis ला होता आणि fourth instantला exactly 90 degree shift झाला. आता ही जी प्रोसेस आहे, आपण एक instant कन्सिडर केलेले वेगवेगळे instant, पण this is the smooth process. Look at it. This is the sinusoidal waveform, and at particular instant we can calculate the resultant flux, and it will be in the continuous shifting. So the resultant will be shifted like rotating, like rotating the magnetic field. Got this? So this is what this is why the resultant magnetic field is rotating in nature. The magnitude is constant, 1.5 times phi m, but the angle is changing. The magnetic field is changing. So look at this. At position number 1, it is on the horizontal axis. Position number 2, it is shifted by 30 degree. Position 3, shifted by 60 degree. And position 4, shifted by 90 degree. So this is how we can say the magnetic field is rotating in nature. What time is it? It's 12:53. Now, the speed of rotating magnetic field. What is the speed of this magnetic field? We have seen that the magnetic field is rotating in nature, but what is their speed? How to calculate the speed of rotating magnetic field? So look at it. This is how we can calculate. The speed at which the magnetic field is rotating, it is called synchronous speed. The speed of this rotating magnetic field is called synchronous speed, denoted by ns, n suffix s. The time instant for represent the completion of 1 quarter cycle of alternating current Ix from the time instant. तर 4 instant बघितले आपण तर त्याच्यात शिफ्टिंग किती आहे 1 quarter cycle म्हणजे 90 degree. The field is rotated through 90 degree. At time instant denoted by represented by 30 or 1 complete cycle, the current Ix from the origin, the field has completed 1. If you consider such a 13 instances, then there will be a 1 complete cycle. एक पूर्ण रिव्होल्यूशन असेल. जेव्हा 13 इन्स्टंट आपण असे कन्सिडर केले त्यावेळेला आपल्याला ते लक्षात येईल की मॅग्नेटिक फील्ड ही कंप्लीट रोटेशन झालेलं आहे 360 डिग्री रोटेशन. Therefore, for 2 pole stator winding, the field makes 1 revolution in 1 cycle of current. आपण हे 2 पोल कन्सिडर केलेले त्याला 1 रिव्होल्यूशन कंप्लीट करण्यासाठी 1 cycle of current, एक सायकल घेतली करंटची. If there are 4 poles stator winding, then it can be shown that the rotating field makes 1 revolution in 2 cycle of current. आता जर असे 4 पोल जर मशीन घेतला हे 2 पोल मशीन बरोबर एन आणि एस पोल म्हणजे 2 पोल मशीन म्हणजे स्टेटरला एका साइडला एन पोल असेल आणि दुसऱ्या साइडला एस पोल असेल. राईट हे 2 पोल मशीन झालं तर त्या ठिकाणी आपल्याला एक कंप्लीट सायकल लागणार आहे 1 रिव्होल्यूशन. पण जर तसे 4 पोल मशीन घेतलं तर आपल्याला 2 सायकल लागणार आहे बरोबर. एक कंप्लीट रोटेशन साठी 2 cycle of current will require. So in general, for p poles, the rotating field makes 1 revolution in p/2 cycle of current. मग जर तसे n number of poles घेतले, p number of poles घेतले आपण तर रोटेटिंग मॅग्नेटिक फील्डचं एक रिव्होल्यूशन कंप्लीट करण्यासाठी p/2 cycle of current लागते. Right? So this is the general expression for cycle of current. So that is equal to p/2 into revolution of field. So we can generalize in equation form. So cycle of current that is equal to p/2 into revolutions of field per second. Now if we are converting into per second, so cycle of current per second that is equal to p/2. So revolution of field per second. Since the revolutions per second is equal to the revolution per minute divided by 60 and number of cycles per second is the frequency f, so the equation becomes means what? If you have to convert into second or if you have to convert into minutes, then divide simply by 60. Minutes मध्ये आपल्याला कन्वर्ट करायचं असेल तर डिवाइड बाय 60 आपल्याला करावं. So therefore the frequency of this motor that f is equal to p/2 cycle of current per second म्हणजेच काय frequency cycles per second that is nothing but the definition of frequency. So that f is equal to p/2 multiplied by ns by 60 and therefore nsp by 120. And if we need to calculate the speed, so rearrange above formula so that we will get ns is equal to 120 f by p, and the resultant speed will be in terms of rpm, revolutions per minute. So this is what the synchronous speed of this rotating magnetic field we can calculate. So it is denoted by nf, where p is the number of poles and f is the supply frequency.